All right, hi guys. So today we are just going to do a little follow-up on my What is Heat video, and today we're going to discuss what is heat transfer and the different modes of heat transfer, because this is very important to know about as well. So what is heat transfer? And we're going to go back and touch on the glowing metal bar because I left something out in my last presentation which was really important, and we're going to discuss modes of transfer as well, which are these equations you see right here. So let's just touch and cue off of this slide, which was from my last presentation. So the last thing from this slide was that radiation agitates the electrons on the surface, and that agitation transfers to the atoms and then distributes throughout all these atoms in this whole lattice from the interatomic bonds, and that's heat conduction and transfer of heat, and this is how an object picks up thermal energy. Okay, so let us continue. So electrons. So the interesting thing about this that I really should have pointed out in the last video is that just as incoming photons agitate the atoms and bring thermal heat into this object and make it warm, that happens in reverse. So an electron that is agitated and moving also emits photons. So think about the symmetry there, right? So these incoming photons will interact with an electron and cause it to move. Well, the exact same thing happens in reverse. In electromagnetism is that an electron, which is moving and agitated and is moving back and forth some frequency, it likewise emits photons. Okay, so the photons come in, agitate the electrons, and as those electrons are being agitated, they're likewise induced to automatically then re-emit their own photons back outwards away from the surface. So just as incoming photons agitate the atoms, the agitated electrons also emit their own photons. And why is that important? Because that is the glow of a heated metal bar. That's what the glow is. That's what you're seeing, is the electrons which are being bumped all around, these electron clouds in the interatomic bonds which surround each atom here. They're being jostled about and agitated by the electron, positron, or proton repulsion, well, by the whole orbital shells here. They're being jostled all about and being accelerated, and accelerating electrons emit photons. This is a property of electrons and how they behave in the space-time continuum. So this is the glow of a heated metal bar, is from these electrons on the microscopic scale are being agitated from the thermal motion of the lattice here that makes up the material, and that likewise emits photons just as the electrons would absorb photons from a warmer source. So the frequency of emission of all the photons that are being emitted from this glowing metal bar is given by this Planck curve. That's what it is. This is the distribution or the intensity of the energy as a function of wavelength or frequency. In this case, it's a function of wavelength, and then frequency is just the inverse of wavelength. So this is the distribution of frequencies. Okay, it's the intensity of energy as a function of frequency, okay, which we call flux generally, right? So that's what the emission is from a metal bar. So at Q equals 0, heat flow equals 0. So if heat flow is equal to 0 because these electrons and these atoms have been maximally agitated by the incoming frequencies, so the frequencies incoming and the frequencies outgoing are the same. So when you get to that state, the curves match each other, and the incoming frequencies can do no more work on the electron agitation rates or frequencies that exist. So these photons, these frequencies are all coming in, and once they have maximally agitated these electrons and the atoms, to what rate? Well, obviously to only the rate of the photons themselves. There's no greater agitation possible than what you are given. So these photons come in and they supply the agitation to the electrons and respond to the electrons, cause the heat flow through the surface, through this object here, but likewise the electrons emit photons, and what photons are the electrons going to emit? They can only re-emit the energy that they've been given. And so there is a balance, and that's why heat flow can eventually equal 0, even though there's photons coming in and photons coming out. They are exactly the same ones because you cannot get out more than what you put in. So the only thing coming out is going to be the same frequencies as what was put in eventually once thermal equilibrium is reached. And so the incoming frequencies can do no more work on agitating the electrons because the electrons and the atoms have been maximally agitated given the frequencies that are coming in there. So very neat, right? So that sort of ties all that together. And again, here's that function. That's that Planck function, Planck's law, Planck's radiation law, which describes these curves, right? The emission, the frequencies of emission. Isn't that nice? I just think that's so neat that eventually we determined, or Planck determined, the nice analytical solution. Can you imagine being the first person ever to have found that solution? That would have really been satisfying, wouldn't it have? So heat transfer modes. So heat transfers only one way, as we know. If we look at these two equations, we have a radiative heat transfer equation, and then let's look at the conductive heat transfer equation. We can see that heat transfer actually looks just the same. You have a hot object, and it's subtracting the energy from a hot object, subtracting the energy from a cold object. And the difference between those is Q. So with conductive heat transfer, that means two bodies are touching, physically touching, what we call physically touching, or it could be also transfer actually within a slice of a body itself. So that would describe heat flow between, say, a single layer of atoms here from top to bottom. And anyway, we see that that's very similar to radiative heat transfer. Though climate alarmists like to pretend that radiative heat transfer behaves in a completely different way according to a completely different set of thermodynamic laws, which coincidentally aren't written down anywhere and they can never refer to. But they like to pretend this because they like to pretend that heat can flow from a cold object in radiation, but not from a cold object with conduction. They think that there's a difference there. Well, there is in fact no difference. The equations take the exact same form in the sense of you have a more intense object with more intense energy and higher frequencies, and then you subtract that energy away from the, or you subtract the cooler object's energy away from that, and then the result of that, the net difference of that's what the heat is, okay? So heat transfers from hot to cold only. And we remembered this plot from the previous slide. So a colder body cannot give what a warmer body needs for its temperature to increase. And what does a body need for its temperature to increase? It needs higher frequencies of agitation. So if we go through this nice set of three equations which perfectly describe everything for us, if we want an increase in temperature here from this term, then that means we need an increase in thermal energy, which is this term, internal thermal energy. If we want an increase in internal thermal energy, then we need, from the first law of thermodynamics, either heat or work. And as we know now, heat and work are actually the same thing, just basically happening on different scales. One is basically happening on the atomic molecular scale, and the other one is more of a mechanical or a larger scale. Okay, so we need heat flow in order to get temperature, in order to get thermal energy increase. And where does heat come from? Heat comes from something about the hot object subtracting the cold object. So what is this difference? What is heat? Heat is this black curve. It's the higher population of frequencies and higher frequencies of agitation. That's what it is. And that's why it can't come from a cold object to a hot object, because a cold object does not have the higher frequencies, the higher rates of agitation that it would have to give to a warmer body in order to warm that body up. And so that is why heat does not flow from cold to hot in either conductive heat transfer or radiative heat transfer. Okay, so very nice and consistent. So why should it be consistent? It is actually consistent because radiative heat transfer is the same thing as conductive transfer, but just at a distance. So look at these two objects here. We have two blocks now, and I have them separated by some, say, vacuum gap, right? Now imagine if these were brought together and touching, then they're touching, and they're transferring heat between themselves if one is hotter and one is colder by physical touch, which we'll discuss in a second. But then you pull them apart and make a vacuum gap in between them, and now the heat is transferring by radiation, and the radiation is simply coming directly from the electrons again. The radiation is a signature of the rates of vibration of the electrons, of the surface. That's precisely what these photons are. So these photons are the signature in space-time of the agitation rates of the surface electrons itself here. So that's why it transfers with radiation at a distance. But importantly, it is actually the exact same force of physics. It is the fundamental force, what we call the fundamental force, because it's, the sort of the base laws of physics by which everything around us runs and reduced to, and that force is called electromagnetism. So it's the same fundamental force. It's electromagnetism. Whether these two objects are touching or whether they are separated with a distance, it is the same force of physics which transfers heat, and that is the force of electromagnetism. So whether the objects are touching or they're at a distance, the information of the agitation frequency rates of the electrons, of the body here, of the atoms, are communicated by photons. And it's basically by electron repulsion or an exchange of momentum via photons. So when objects are touching, we have to consider what actually is physical touch. Physical touch is actually a very abstract concept. There's actually no such thing as physical touch. When you touch something, or if these two objects were to be laid on top of each other touching, there is no physical touch per se. What's happening is that the electrons are repulsing each other. Okay, the electron clouds are repulsing each other through an exchange of momentum from photons. That's how they communicate. So how does an electron communicate with another photon that they should repulse each other? They do that with a photon. And that's presented here, or represented here with this, what is called a Feynman diagram, showing the quantum interaction of you have an electron here coming into the vicinity of another electron down here. And what happens is they exchange a photon, and this exchanges information, but it also exchanges momentum. Photons are massless, but they still carry momentum. And so this electron gets pushed backwards the other way, and that electron, gets pushed the other way, and this electron likewise gets pushed this way because of this exchange of momentum caused by this photon. So that's what's actually happening. There is no touch per se. All that's happening is that a virtual photon or a photon is being communicated between these electrons and telling them to repulse each other, and they do that through an exchange of momentum. Isn't that neat? Isn't that interesting? So there's no physical touch. There's just electrons repulsing each other through the exchange of a photon. That's what actually happens, okay? So that happens in touch with these electrons very close to each other, but at a distance, the same thing is happening. The electron being agitated, being accelerated, the result of that is the emission of a photon. So the photon is emitted, and then it'll come up to this object, say, and now this electron will see that same photon and it'll be induced into that same agitation because of the exchange of that photon, the information in that photon. So it's actually the same thing because it's the same laws of physics, and that is why the equations actually look the same and why there is no magical reverse heat flow with radiative transfer, as the climate alarmists and the climate alarmist greenhouse effect believers pretend to say, the flat earth believers pretend to say. They pretend that in radiative physics that that heat can flow from cold to hot. But in fact, if you look at the equations have the exact same form where heat only flows from a hot object to a cold object. And the reason is because it's an exchange of information of higher frequencies that can be induced into the cold object. And of course, the cold object doesn't have the frequencies to induce in the hotter object that the hotter object would require in order to raise temperature. So isn't that all very neat and nice? So modern science, I want to make a point of this, loves flat earth theory. I mean, we can have all these very technical discussions about what is heat and what are the equations for heat flow, and often you have to get into this because the climate alarmists totally ignore it and don't want to talk about it. And as you saw in my debate, when you present them the equation for the heat flow, they're like, oh, well, I've never seen that equation. It's like, so you're telling us about heat flow and how heat flow works, and then we present you with an equation and they've never seen it before. That happens all the time. I mean, I don't actually know that person that I was debating, but that debate went exactly how it goes with any professor, PhD in climate science that I've ever talked to. They all act like that. So they love to talk about heat flow and how heat can flow from cold to hot, but then you show them the equation for it, and then they're like, oh, well, I've never seen that equation before. Isn't that amazing? But, you know, this isn't just in climate science. This is science-wide. You know, astrophysicists and physicists, they love climate alarm. They love it. They all support it. They all love it. It's the jewel. They just love it. It is they believe it is the most important and valuable science that has ever been produced by the academia for political and public consumption ever. They just love it. They just love it. And as we have seen, it's actually based on flat earth theory. It is actually literally the physics of flat earth theory. And, you know, I've made this slide here which shows the difference. So which would you prefer? Would you prefer a spherical Earth where the mathematics of a spherical Earth works out to the sun creating the climate? I mean, isn't that amazing? If you work out the mathematics for this, you get two really different results. So if you work out the mathematics for a spherical Earth, you find the result that the sun can create the climate with its heat, that the climate is the transfer of solar heat through the atmosphere and through the Earth. The input transfers through to the output, so a very hot, warm solar input transfers to a cool output. It's physically and mathematically realistic because obviously we do have a spherical Earth and sunshine is quite warm and the sun does create the weather. It's consistent with thermodynamic laws because if you apply the thermodynamic laws to this, you get these results. It's empirically observable. You would observe this from outer space. And the funny thing is that if you try to submit this through modern physics journals, and I've tried several journals, including physics journals, not just the meteorological journal, which is a few videos back, which I showed you guys. I've also submitted it to physics journals, and they also reject it. So this idea, this model of the solar heat's interaction with the Earth is not acceptable to peer review science. It's not acceptable to modern science. They hate it. They reject it. Isn't that hilarious? Whereas on the other hand, if you have a flat Earth model, literally, look at, it's a flat line, flat line, flat line. They're all doing flat line, okay? And you work out the mathematics for this. I mean, it's just so amazing philosophically how this works out. So you work out the mathematics for how would the sun have to work with a flat Earth? What would be the physics result of the sun falling on a flat Earth? It's amazing how it works out mathematically. And this is what they actually show in their diagrams. The sun cannot create the climate. That's a result. You get the result that the sun can't create the climate. And then you have to invent this fake greenhouse effect where the climate creates itself out of nothing. And in fact, in their peer-reviewed literature, they show that the atmosphere provides twice the heating power than the sun provides. So the climate creates itself by the atmosphere providing twice of its own heat to itself, or twice more heat to itself than what the sun provides. That's the mathematical result, and they believe it, and they have numerous peer-reviewed publications upon which they base all of their interpretation of climate theory. And that's their starting point of climate science. It's mathematically, physically, theoretically, and graphically equivalent to flat Earth, inconsistent with thermodynamic law, because then they need to go to this reverse heat flow thing where they think that radiation heat transfer is different than all other modes of heat transfer, and that in radiation you have a special case where heat can now somehow magically flow from cold to hot. It's empirically fictional. What is this? It's a fiction. It's a fake version of the greenhouse effect refuted by real greenhouses. Real greenhouses could demonstrate this physics. You could work out this physics and say, I postulate that this is how a real greenhouse functions with its ceiling and its surface, and this is the air inside. I postulate this model, and you go out and test it, and you find that the temperatures which should be generated by this model do not happen. The only temperatures generated inside a greenhouse are that from actual direct solar heating. You do not find this effect. So all greenhouses in the world provide empirical evidence that the climate alarmist version of the greenhouse effect does not function. And so this is peer-reviewed climate science. It's widely accepted. It's accepted almost across the entire board of science, including astrophysics and physics and quantum mechanics. They all love this stuff. They all promote it. They all hate on people like me who are the climate deniers, as if that term even means anything. Yes, I deny the climate. I deny the climate exists. I mean, these are the types of terms that they use. Of course, they use them because their brains don't work anymore. There's something that I should comment on that actually. You know, there's something that happens to a certain type of person when they have a degree conferred upon them. And this is the midwit class. So you have the midwit class, which is probably between about 115 to 125 IQ. So this is the midwit class, the people of middling intelligence. If you confer a degree on these type of people, it destroys their minds. It just destroys their minds. So these are the people going through academia, these are the people getting degrees, and once they get that degree, it wrecks them. It destroys their minds. And really, their IQ drops from about an average of 120 in the midwit IQ class. Once they get that degree, the moment of conference of the degree, of the title of PhD or doctorate of physics or whatever, doctorate of climate science, they get that degree and their IQ literally plummets to about 78, I've calculated. So they literally have a crash in IQ. Once they get those letters and they think that they are a brilliant, smart person who deserves to be called a doctor or a PhD, their IQ will drop from 120 to about 78. And I've talked with people like this who have PhDs in physics and astrophysics, and I've said to them, do you really think that it's reasonable to start our understanding of the climate with the proposition that the sun does not create it and that the sun does not heat the earth, because that is a consequence of mathematical flat earth theory and mathematical consequence of flat earth theory? And you know what they say to me? They never answer it directly. They never just answer that question directly. I've never had them answer me directly that question. What they do instead is they go into some other territory and give me an answer like this. For example, they will say, well, for the trajectory of a baseball on a baseball diamond, we use flat earth theory, and that works, so there's nothing necessarily wrong with flat earth theory. So I don't see what you're criticizing. That's literally what they will say. Now, you guys, you obviously understand the point here, right? A baseball diamond is actually flat because it's been engineered to be that way. And a baseball flying over that baseball diamond stays within that geometry of a flat baseball diamond, right? So you're actually modeling something that actually exists. Here on the left side of the diagram, we're modeling something that actually exists. The spherical Earth actually exists. And when you do that, the math works out that the sun heats the Earth and creates the climate. What are you modeling here with this flat Earth for the entire Earth? This isn't just a baseball diamond, a small section of the Earth. This is representing the entire Earth. And it's saying that sunlight is falling over the entire surface area of the Earth. This does not exist. I don't know why physicists can't understand this these days. This does not exist. You're modeling a fiction. And so what is the result of modeling a fiction? Well, you get fiction out of it, such as reverse heat flow from cold to hot. All right, so if you would like a bit more detail on all of this sort of stuff, you can go check out my two books. My first book, In the Cold Light of Day, and my second book, The Layman's Guide to the Greatest Scientific Fraud in History. I go into a bunch more details. You'll learn a little bit more about how scientists could have made this mistake and why they made this mistake. And in The Layman's Guide, you get a nice simplified discussion of it all. In the Cold Light of Day book, it's a little bit more complex, but it's still pretty fun. And if you really, really want to understand the sort of academic class today, the university class today, and how they could have made this mistake. I mean, guys, this is what do you even call this? What time span do you need to address in order to find a mistake like this? A bunch of smart people who are supposed to be smart making a mistake like this. I mean, where do you go in history? Like I always say when people talk about boomers and what boomers have done to the world, I say, well, yeah, you kind of got to go back to like biblical days, the days of Noah, the days of like, Sodom and Gomorrah in order to explain the boomers. I don't know where to go to explain modern scientists or to describe modern scientists in this mistake that they've made of loving flat earth theory and incorporating flat earth theory into modern physics. I don't know where you go for that. I mean, it's really quite unique. It's really an absurdity which has no comparison. Uh, it's, I mean, it's really itself a form of profundity. You know that expression profundity? Usually it's used for when you are grasping the magnificent scale of the universe and the galaxies and the intergalactic voids and the beauty of it all, or the beauty of a child being born. But profundity, it's a consuming sense of sublimity that you almost cannot comprehend. You know, that's the kind of feeling I would get from astronomy. But that's kind of where you have to go to think of modern scientists loving flat earth theory and defending flat earth theory in peer-reviewed climate literature and peer-reviewed physics literature, and rejecting in peer review the concept that the sun heats the earth. There's no comparison for this. It is really going to stand as a testament to something really, really important that we need to understand about humanity. It's going to stand for a long time. It's going to stand forever. It's a statement of some kind about humanity, and I'm not sure if it's not a good statement. It's not going to be a good statement. Like, it's going to be a statement about our gullibility or about our general stupidity. It's really not good, you know. And I hope we survive it. I hope we do. At least I've survived it, and I know that most of my watchers, people who understand what I'm saying, we survived it. We're going to have to survive it, guys. It's going to be us. And somehow we're going to be the ones that have to survive it. And we're going to have to look back, and we're going to have to figure this out and see who made this happen and what was their mind space to allow this to happen. This midwit class, what is their mind space that allowed this to happen? And we're going to have to make sure that these people are never, ever allowed anywhere near science and physics ever again. And yeah, that's basically everyone that's in science and physics now. They all love flat earth theory. They all love climate alarm flat earth theory. And if you point it out to them, they just, actually here's another example. So I was told once that in the olden days, coastal fishermen, people used to fish, like, think thousands of years ago, who are those people that lived in Hawaii, the Polynesians and all them, they did a lot of fishing, right? But they believed that the earth was flat, and that's why they never ventured very far from their islands. And so I was told that even though these people believed that the earth was flat, it never stopped them from catching lots of fish and being very successful fishermen. And therefore, there's nothing necessarily wrong with flat earth theory. That's literally what scientists have told me. That's literally the arguments that they have presented to me when I try to have a conversation to them about math and physics and if the sun heats the earth or not. That's literally what they say in response to me. So we can't let these people in the future anywhere near science. I mean, that's just the result. We're going to have to keep them away somehow. We're going to have to figure out a system for keeping these people away. Now, if you want a really, really good book, a friend of mine, well, not really a friend of mine, I don't know who it is. This fellow, Joe Dixon, The Mandarin Effect, The Crisis of Meaning. This book is actually all about science and academia. It explains to the T. If this is of interest to you, if you want to really understand the mindset of academia, the mindset of the university system, how could they allow something like flat earth theory to enter modern physics? This book doesn't talk about flat earth theory and modern physics, anything that I'm doing, but it just talks about what are these people? Who are they? What is their mind space that can allow them to make such gargantuan, hilarious, and absurd mistakes as they have? This book is excellent. It will tell you in depth all about the psychology of these people and who they are and why they have done what they have done. So, hope you read that. Hope you read my two books, and have a good afternoon, everybody. Bye-bye.